Hello, I'm Sanghyuk from Naver AI Lab. Today I'm going to talk about our paper, Language-Only Efficient Training of Zero-Shot Composed Image Retriever. This work is collaboration with Geonmo and Yoohoon Kang from Naver Vision and Wonjae Kim and Sangdoo from Naver AI Lab. Composed image retriever is a retrieval task taking an image and a text instruction as the query, aiming to search the relevant image in the database. CIR is a challenging vision language task that requires the understanding of both visual and textual information. Traditional CIR method require expensive triplets of source image, text instruction, and target image. So we call this one as CIR triplets. In practice, collecting these CIR triplets is expensive and difficult to scale up. Recently, a number of zero-shot composed image retrieval approaches have been proposed by eliminating the dependency on the pre-collected CIR triplets. Now, the mainstream of zero-shot composed image retrieval is based on projection from the image feature space to the input texture token embedding space. So we have core image here. We encode the image to some feature, and we project the feature to the texture token embedding space using this projected feature. And then we just take the text to image retriever using the pre-trained texture encoder. So these projection-based method eliminate the dependency to triplets by minimizing the distance between the visual feature and the projected text feature using a fixed prompt like a photo of something. So we usually minimize contrast loss between this visual feature and texture feature. So there are two methods like pick-toward and stutter tackling this problem in this projected method. Although they show quite good results, they suffer from limited backbone scalability and generalizability due to the lack of diversity of the input texts during training. So to tackle the issue, we propose a novel zero-shot composed image retrieval framework, Linker. Linker is trained only with text inputs, so it is very easy to scale up, and it shows very good generalizability. So Linker minimizes the distance between the projected text feature and the original text feature. So to make this projected feature, we replace all the keywords in the given text to the projected token. So here, keywords could be like gray cat or a pillow. So it is because we want to make the projected feature capture the important semantic in the text or image. And keyword is usually the most informative part in the text. However, this approach will still suffer from the modality gap between visual and textual features. So we mitigate the issue by adding random noise to the text features before the projection. This simple approach reduces the gap between two modalities and shows very good generalizability. During inference, we simply replace the texture encoder to visual encoder and use the same retrieval framework as other projected methods like pick-toward or stutter. So here are the experimental results. So Linker has two advantages against previous method. So first, Linker has very efficient training in the training time and the storage time. So we usually take less than 2 or 3 hours, even for the VITG backbone, which is very, very large one. So the other method, like Pictor, takes more than 10 hours for training just simple projection method, projection layer. We takes much efficient training time. And also we achieve very good performance because the linker allows the texture encoder to accept more diverse captions rather than a photo of something. So it makes the texture encoder and the projection method more robust to the input text. So we can take more diverse captions and it causes more better performance. As a result, linker easily scale up in backbone size and dataset scale. So our implementation is publicly available in this GitHub repository. So you can visit our repository to reproduce the result. Thank you.